Hello everyone, welcome to Lecture 5. Okay, so let's get started. So remember we were talking about sort of the beginnings of modern astronomy and the Ptolemaic system that was Earth-centered, remember that, right, geocentric, and really people call it the Earth-centered universe because to Ptolemy and people of his time, they really didn't think about much else besides that the Earth was the center of the entire universe. Um, so really, it's really more of an Earth-centered model of the solar system, not the universe, but people call it the geocentric view of the universe. Now, this particular view was very successful. It ruled for roughly 1,300 years, and that's a very long time. Now, Western Europe, of course, saw the crumbling of the Roman Empire during that time. By about 500 CE, and that remember, CE is Common Era, stands for Common Era, and that is really AD. So if you're not familiar with that, we said that before briefly. So we're used to sort of BC and AD, but people very commonly now use before the Common Era, BCE, and CE, Common Era, to mean basically the same thing. So by about 500 CE, all the scholarship really had moved to the Middle East. Europe was starting to suffer the Dark Ages, and knowledge and science really were not their main concern at that time. So luckily, all of that knowledge, a lot of the Greek knowledge, was not lost because it really was taken up by people in the Middle East who were sort of having a good period of scholarship and increasing knowledge, and they really valued science and learning. Okay, so Europe really didn't wake up until about the 14th or 15th century, so quite late. And the ideas of Aristotle and Ptolemy were really accepted by the Catholic Church at that time. So let's just remind ourselves why this was a successful theory in the first place. Let's go to a simulation, and I'm going to go to, here's the a Ptolemaic system simulator. Now remember that Ptolemy really came up with this to explain retrograde motion, right? So then we talked about that before, and we saw a video of that. If you watched planets over days and months, you would see them moving in one direction, and then turning around and stopping, turning around and moving back the other direction, stopping, turning back and moving the other direction, doing these sort of loop-to-loop motion. And to explain that with a geocentric universe or solar system is kind of tough. But Ptolemy came up with this kind of ingenious method of figuring out how to make that happen. Now, we didn't really discuss this, but at that time, of course they knew about gravity, meaning that they knew that if you drop something, it would fall to the ground, right? They didn't know why that was the case, and they certainly didn't know that gravity is what made the moon go around the Earth, right? Or in their view, the sun go around the Earth, right? They did not know that there was something called gravity. So when Ptolemy made up his model, he wasn't trying to figure out what could make the planets do these crazy motions, meaning what force. He didn't even really think about force in that way. So when I run the simulation, it's going to seem a little crazy because remember that in Ptolemy's model, there were these little circles. So there was the big circle of the planet going around the Earth. Remember, everything goes around the Earth, including the sun, right here, okay? But the planets also go around these little things called epicycles, which are these other circles here. So let me start the animation and we'll just talk as it goes. So this is supposed to be Mars, right here, moving fast here, okay? This is supposed to be Earth, okay, and there's the moon. And the planets, let's pause. So the planet, see, goes around in a big circle. So this is the sort of big circle with a little circle center. So the center of the what's called the epicycle, which is this thing here, goes around the big circle here, but the planet is going around this little epicycle at the same time. And as you can see this loop-to-loop sort of thing, if you were watching from Earth, right, you'd see the planet go in this direction and then it's turning around and going the other direction, right? So this epicycle was really meant to mimic this. Let me slow it down a little bit. Oh no, that's going faster, sorry. Here we go. Okay, so you see the epicycle, see the planets going around that little circle, smaller circle. And it's going to do its loop-the-loop in a second and execute retrograde motion. Okay, so rather ingenious, but again, if there had been a theory of gravity, and that didn't come along till Newton, okay, if there had been a theory of gravity, this would have been something he couldn't have come up with, right, because there was no way that gravity would make planets move this way. But he didn't know about that, right? He was just trying to come up with a model for the solar system that would reproduce what people saw in the sky. And it was rather successful. So this is one of the reasons it lasted so long, not because people were dumb, but because it actually worked pretty well with the knowledge they had at the time. So now, as we know, we do not live in a geocentric universe. So it was really Copernicus who first made this a famous idea, and that he wasn't the first to think of it. So Aristarchus, if you might remember, proposed that the Earth goes around the sun, and several Middle Eastern scientists also didn't, the idea that the Earth sat still and things went around it really didn't sit well with them, and so there were some publications to that effect. But it was really Copernicus that sort of made the big dent in this. He published his paper Revolutions during the year of his death, so it took him a while to actually publish, and he had to be urged to do that, to publish this work. As you imagine, it's pretty controversial. And of course, he believed the sun was at the center of the universe, because that's really how they were thinking, right? Either the Earth was or the sun was the center of the universe. Of course, we know that's not true now. All the planets, including Earth, orbit the sun. That is correct. Now, he didn't get everything right. So, for instance, he believed that planets move with constant circular motion. That's not true. But he did say correctly that Earth spins on its axis. His Revolutions really, paper was quite influential and got a bunch of things right. And of course, as you know, caused a lot of controversy. And one of the things that really pointed him in the direction of this, of the heliocentric universe, was the retrograde motion is much simpler in that case, right? It's a simple case of Earth catching up and passing planets in different orbits. And it only seems the planets are moving backward, but in truth, they're just falling behind Earth. So this is a really much simpler explanation. And one of the things we haven't really talked about in science is that there's kind of a guiding principle, and it's called Occam's razor. And I don't know if you've heard that term before, but it means that the simpler the answer is, the more likely it's the true answer. And that's not always true. So if you look at some really complex systems like the brain, certainly the simplest answer is not the answer for, why we think certain things or whatever it is, right? Or human consciousness. And but in general, when you think about astronomical theories and theories in physics and chemistry, there's sort of a beauty and an elegance to solutions, and that's sort of a guiding principle. That the simpler the answer, if you don't have to go through a bunch of machinations to get something to work, then most likely that's not the right answer. You haven't come up with the right answer. And as you can see or remember from Ptolemy's quite complicated model with these circles and other circles, the epicycles, and the planets sort of whizzing around, to get retrograde motion out of that, right? So, to explain retrograde motion in his, to keep the Earth at the center, you have to do all these machinations, right? But if you now put the sun at the center, retrograde motion is simple. So let's look at a simulation. So we looked at a Mars simulation, retrograde simulation before, and we saw a video, but let's look at this one. So just to show you, here is the path of Mars, right? So going this way, and then, right, turning around for a little while, and then going back this way again, right? So the sort of loop-de-loop that we saw that Ptolemy's model was pretty good at doing. And here's the same thing now, but with the heliocentric universe. And let's take a look at how that works. So look at, here's Earth overtaking, see? And so this is the view from Earth, right? Obviously, Mars doesn't actually go backwards, but in this model, right, Earth just overtakes it. Earth is going around the sun faster, right? So the idea that the planets are just overtaking each other and that causes retrograde motion is much simpler than a bunch of crazy circles and other circles, right? So let's make this go a little faster so you can see it. This crazy whipping around and all that, right? I mean, this worked, but it certainly isn't very simple. All right, but that can't be the only reason that we accepted that the Earth is not at the center of the solar system. Let's see. The big other clue were the phases of Venus. So Venus can go through phases, and if you have a telescope, kind of need a telescope to see them. Can't really see them with the naked eye. You can certainly see Venus with the naked eye, but you can't really see the phases. So the phases of Venus really depend on the type of universe, right? Heliocentric, or geocentric, Ptolemaic universe that we're looking at. So in a geocentric model, right, Venus only really has crescent phases. So notice here, right, here's the light up here, light up here, light up here. You can't see it here because, yeah, well, you can actually, but we don't really see that. And then here's another crescent, another crescent. But if we have a heliocentric or Copernican universe, then Venus can have many phases. So notice here's like a half phase, right? Here's sort of a gibbous. There's crescents. There's all kinds of phases. So let's look at another picture of that. So it's a little better picture. And here's an actual picture of some of the phases of Venus. And notice it gets a little bigger as it gets a little closer to us, right? So this model, the Copernican model, really was the only way to get these phases that people could observe. Now, again, you couldn't observe it with a telescope. So it really wasn't until Galileo, who used a telescope, made really great use of a telescope, where he really saw these phases very clearly and showed, wow, look, there's just no way to account for this in a geocentric universe. But we haven't gotten there yet. Anyway, let's do a question. So retrograde motion is best explained by relative motion between two planets in different orbits, with one overtaking and passing the other. True or false? Well, that is the best explanation, and by best, we mean simplest, right? That's what I was explaining, because if you have to go to crazy circles and other circles, whereas if you just stick the sun in the center instead, and you get an explanation, sticking the sun in the center is the better one because it's simpler. So that is true. All right, it's time for your quiz question. Don't forget to pause the video